Ladies and gentlemen, it's now time for the Innovation Awards. The abundance of high-quality applications from Belgium, Brazil, Holland, Italy and Germany once again presented the Biopolymer Innovation Awards jury with an exciting and challenging task this year. We were very pleased with all the entries. The jury was made up of high-caliber members and held, in part virtual, very constructive and enthusiastic discussions. After a multi-stage selection process, the jury nominated 3 companies as candidates for the main prize of €2,000. The high-quality samples submitted met the requirements and already have a certain industrial maturity before entering the market. The jury was naturally very pleased about this. Unfortunately, the awards cannot be handed over in person, but we are looking forward to announcing winners at the award ceremony. During the award ceremony, the winners will present their projects and will be available to answer questions afterwards. But first, let us introduce our winner in 2021. Mr. Stefano Mele from Gruppo Fabri presenting his idea. Let us listen what, after winning the award in 2021, has happened. Film rolling.
Hello everybody, I'm Stefano Mele, I'm the CEO of Fabri Group, and now I'm going to introduce you to Nature Fresh and in particular how plastic packaging goes organic. As Fabri, we are fresh food packagers, means that we are producing machines and film for our customers that are packaging the fresh food, means meat, fish, alternative proteins, fruit and vegetables. And we do it with a full range of products for the automatic packaging, as well as with plain and printed flexible films, and among which we have been now developing through the time sustainable and complete packaging solutions. In this strategy, we considered to support the circular economy with innovative materials, already with a project that was started in 2015. We believe that we need to have a more sustainable solution, and for this reason we developed Nature Fresh. What is Nature Fresh? It's a compostable certified cling film that is possible to be used on our machine as well as also of our competitors. And it's a film that is printable with compostable inks, has a very high water vapor permeability, even higher than the traditional films, and offers, as the others, a full protection to the freshness and the properties of the product that are protected with our film, and therefore is ideal for any kind of fresh food. And this project we have been developing with the support also of the European Commission within the project Horizon 2020. And here we see the Nature Fresh features and benefits. First of all is the first product on the market that is compostable certified for automatic and manual food wrapping. And it respects all the standards of the EN 13432 on a global scale, and it is also certified for the home compostability. It uses a special grade of the polymer EcoVio developed by BASF, of course, together with us, and it helps to reduce or to eliminate the packaging waste. It has, as we said before, a very excellent water vapor transmission, and this guarantees that the products are properly preserved and protected. It is a very thin film, so it uses the lowest amount of possible plastic for the utilization, and it is approved also for all type of foods, also the products with very high fat content. After 2 years from the launch of Nature Fresh on the European market, we have been producing it already in hundreds of tons and thousands of film reels, with which millions of compostable food packages have been produced. We have already a lot of different customers in Italy, Germany, France, UK, and exploring also further in other countries and in other regions. And last year, we were very proud to win the first Biopolymer Innovation Award. Based on the success of Nature Fresh, we have now started to develop a new compostable film for MAP packaging. That is the second way of packaging fresh foods that is made with our film and also with our machines, especially from the lines Caveco, Toplit, or Xpeed. On this new film, we are already in test with different customers and will be launching it into the next period of time. Because we believe that together with traditional solutions, more innovative and sustainable film have to be produced on the market, and this will lead to a better understanding and better utilization of the circular economy. Thank you very much.
Thank you, Stefano, for the review. We are happy that your idea is so well spread on the market and wish you all the best for the future. And now we are very pleased to announce the award winners. They will now present their ideas to us in short talks and will then be joined live for the awards ceremony. We will see the videos in alphabetical order. The first one is the film from Pedro Lutz of Earth Renewable Technologies from Curitiba in Brazil, with his presentation on short fiber reinforced in FC 10130 composite. The second video will be from Kai Kölzig from SACHSENLEINEN GmbH from Merkliberg in Germany, with his innovation about Fuse HMP thermo UD tape. In the studio for the live session, we look forward to seeing Lovis Kneisel then. And the third video will be by Pierre de Kettenis of Home EOS from Fischer in Belgium, with his presentation on the biopolymer stop sound. Enjoy the films.
First of all, my name is Pedro Lutz, and I'm the responsible for product stewardship at Earth Renewable Technologies. It's called ERT. So we are an industry was born in the USA, and we have moved to Brazil since August 2021, the main sugarcane producer in the world. So today, I'm honored to present it to you our amazing Sfrp microfiber technology, which we are competing for the Biopolymer Awards 2022. On the right side, you can see the microscopy Sfrp image. You can see the microfibers present inside a PLA fiber that are immersed in a PLA matrix. Performance is the goal of the 10 series with the exclusive and revolutionary microfiber technology Sfrp. It is possible to combine the advantages of polymers, PLA, good impact resistance, low weight with the high stiffness, and it can be improved elongation at break and HDT. So thermoplastic SFRP is suitable for mass production now in RT. A very important point to make it is that technology is already used in RT in mass production. In this slide, you can see a well-known graphic and materials engineer, stress versus strain graphic. So see in yellow line, the product ERT SFRP PLA compared to conventional PLA in a blue line. See that the yellow presents a high deformation and the blue line does not. Look this example in this photo on the right. To make the explanation more visual, please see this phenomenon occurring in these videos. Look on the deformation of the fork. It can achieve compared to the fork of a conventional product on the right. Also see in this other example below how this specimen can deform. It is incredible. And in this example on the right, see the effect occurring in straws tubulars. See the strength of the straw with SFRP technology. Now I presented to you images of our final product. So nice, simple and usual product, but with a really interesting technology inside, able to competitively enable PLA for use in these applications. Here are some properties that we were able to achieve with our ERT product compared to neat PLA from L130 on the right side. Look at the significant increase in the strain at break of the ERT product in their amorphous states. Here are the significant increase in impact strength of the crystallized ERT product. Now, look at the thermal deflection temperatures. Look at the HDT achieved by the crystallized ERT product. So we are a biodegradable plastics company, but more than that, we are a compostable bioplastics company. See this example of biodegradation occurring in the second of the images on the right. This is the one of the tests to comply with EN 13432, which we are certified by the main certifying agency in compostable field. It's called TÜV. So our products are certified by OK Biobased and OK Compost. It is confirming that our raw materials are bio-based carbon, and also final products have an end of life, compostable. Thanks a lot for the opportunity. It is SFRP Technology by ERT, the company that reimagines plastics for a regenerative world.
My name is Kölzig. I'm a development engineer at SACHSENLEINEN, and I'm very happy about our nomination for today's award. Since we only have a little time, I would like to explain to you in a short discourse about the value chain from the field to the end product, who we are, what we do, and what exactly FUSE actually is. FUSE stands for Fibers in Use and was developed by SACHSENLEINEN. That's the company I work for. We are a small interdisciplinary team that deals with the entire value chain from fiber plant harvesting to fiber extraction and textile processing up to fiber composite products. Our big goal is to establish regional natural fibers in combination with bio-based plastics and technical applications, and thus contribute to drastic reduction of CO2 emissions in the composite market. Our core competency is to develop tailor-made fiber composite materials for lightweight applications, such as the FUSE UD tape with which we are nominated here today. Our focus is on hemp fibers, as they offer largely untapped potentials in terms of performance and price, and as well, many other high performance properties. But what means high performance in the case of natural fibers? What can such material systems achieve? The main focus here is on properties in which natural fibers are at least equal or even better than other materials. These are properties that other materials do not have, and thus bring them a unique selling point and special product characteristics. The following three aspects are outstanding. First of all, the excellent damping properties of hemp fiber reinforced biopolymers. A component made of such materials has a 50% higher damping capacity for unwanted vibrations than a comparable glass fiber component, which is very interesting in dynamic or acoustic applications. But also the low splinter fracture behavior in crash-relevant components is a very advantage feature. The second big advantage is, of course, the sustainability of the materials. Compared to our direct competitor, glass fiber, we can demonstrate an 80% lower CO2 footprint. Bio-based fiber composites offer the possibility to keep carbon in closed loops and even store it for a long time in the products. Only little energy is needed for the production because the fiber grows in the field with the power of the sun. The use of local raw materials also helps to minimize energy-intensive logistic efforts, which increases the sustainability of our value chain even further. But also the mechanical performance of biocomposites does not have to fear the comparison with its synthetic rivals. Due to the very low density of approximately 1.2 grams per cubic centimeter and the high specific properties, it can easily compete with the glass fiber composites. A clever construction and innovative design provided. Clever in this case means rethinking your products. You can compare this with the evolution that took place when steel was replaced by carbon fibers. It also took several years to reach today's perfection in component design. My favorite example here to illustrate this is the bicycle frame. Current high-end bikes have little in common with the steel models of 20 years ago. But the manufacturing processes are also changing. A good example is the coreless winding of the University of Stuttgart, which resulted in this pavilion made of natural fiber composites. But why do we still see so few products made of natural fiber reinforced bioplastics, even though the technologies and processes are available? On the whole, there are two reasons for this. Firstly, the high price of the materials, and secondly, the partly insufficient industrial suitability of the semi-finished products. Fuse Hemp Thermo was developed with the aim of solving exactly these two problems. We have developed a process that eliminates many steps in the textile process chain and sets new standards in the economics of bio-based fiber composites through high efficiency and flexibility. To put it in simple terms, we can reduce costs by up to 40% and at the same time respond very precisely to the requirements of our customers and their applications. Fuse Hemp Thermo is available with variable grammages from 80 to 250 grams per square meter as a continuous surface with up to 1,000 meter per roll. Suitable fiber types are flax and hemp, but I would not rule out wool or pineapple fibers either. With the biopolymer, it looks similar. We have already successfully processed PLA and PA1010, and PA11 will be soon investigated. So what can you do with Fuse Hemp Thermo? There are no limits in your imagination when it comes to applications. We are currently working with customers from the sports industry, micromobility, and furniture construction. The skis and poles in the picture are the first prototypes in which the amount of glass fiber was successfully replaced by natural fibers. With this inspiration, I would like to conclude my presentation. As you can see, the sustainable materials of the future are already within reach. Now it's your turn as a user to bring them to market with innovative products. We can support you with this. Thank you very much.
Ladies and gentlemen, welcome. It's a pleasure to share with you our passion for sustainable development, and it is an honor to be invited to present our modest contribution to a zero-carbon economy. Homeos is a small, innovative company founded in 2016 in Belgium, and we look forward today to discover with you the winners of the award today. Homeos provides bio-based polymers for three major sectors: construction, industry, and transport. It's very innovative material made through a disruptive technology. Our biopolymers are based on organic byproducts from agriculture. They are a green chemistry to value raw materials from a circular economy. and they provide solutions to serve the Green Deal and sustainable development objectives. Our goal is to provide society with healthy and sustainable products for a better quality of life. A disruptive technology because it is the first bio-based polymer in a water phase. We use only organic compounds that are renewable, easy to collect from nature, and mainly based on polypeptides, starches, and polyols. We use also mineral fillers for the application that require mass loaded. And the technology is patented in Europe, US, Canada, China, Australia, and New Zealand. These sustainable polymers are recyclable and biodegradable. They're made without solvents, without plasticizers, without flame retardants. Although they are resistant to fire, without any additive, and Euroclass B1 S1G0. They also have a low thermal conductivity, so our lambda is 0.05. They have high acoustic performance and vibration damping, and a very low dynamic stiffness. So that viscoelasticity, as you can see on this sample, it's very easily to compress, very soft material that is made through this technology. It's a very low carbon process that also requires very little energy. We can do a lot of different products with this technology. One of these is the acoustic membrane that we name Stop Sound. It's very effective against low frequencies. It's reduced 30 times the transmission of noise and absorb vibration. The feedstock that we use are coming from byproducts from agriculture. They're suitable in the form of polymer for casting, but also for molding and for injection. And today we sell mainly this product as alternative to bitumen, PVC, and EPDM. The main applications are in buildings, drywalls, roof, partitions, screeds, flooring, in industry as engine encapsulation for noisy equipment or piping, wrapping. We also propose this material as a substitute for bitumen in the transport systems. In the building, the majority of the buildings that have a light structure, like wood construction, but more and more other sectors of the building will go for light systems, and providing additional acoustic performance is a must in these buildings. For factories, we see, for example, production office control rooms, insulating power generators, and in the transport system, systems like ships or trains or even automobile are all looking for replacement for the rubber that they use today. Thank you very much for your attention, and feel free to ask more questions.
Thank you very much for the presentations. And now with us in the studio, live, Pedro Lutz, Pierre de Kettenis, and Lovis Kneisel. A warm welcome. Nice to have you here. Hello.
Nice to meet you.
How are you?
Hey, man. Thank you.
Okay, so who will receive the coveted prizes for outstanding innovations in the field of bio-based, biodegradable plastics in 2022? Right, we are very pleased that Miss Simone Fischer, responsible editor at Plastverarbeiter and member of the jury, will give a laudation to the winners. Welcome, Simone Fischer. The stage belongs to you.
Thank you very much, Mrs. Witt. I am now pleased to announce the winners of this year's Biopolymer Innovation Award. Before we commence with the awards, I would like to quote Wolfgang Sachs, who is scientist, university lecturer, and a publicist in environmental development and economics. There is no sustainability without development. In my opinion, it cannot be summed up any shorter or more aptly. but the development time for new products and materials is not as short as the quote, because it is less like a short distance run and more like a long distance run or even a marathon. The entries from Earth Renewable Technologies from Brazil, Home EOS Technology from Belgium, and SACHSENLEINEN from Germany successfully mastered this distance. The developments convinced the jury members and were deemed worthy of the award. I am now honored to present the awards. Let's start with a company that was founded 12 years ago in the United States of America. Together with Clemson University in South Carolina, short fiber reinforced technology was developed and patented. With the developed fibers, it is possible to improve the mechanical properties of biopolymers in a bio-based way. The source of the biofibers are plants and other renewable materials from agriculture, marine, or forestry. Using this technology enables us to continue manufacturing disposable products such as straws or disposable cutlery with the benefits of plastic. If these end up in the environment, they pose no problem as they decompose in 180 days, according to the manufacturer. The company has been operating in Brazil since 2021 as it aims to solve the plastic problem in a country where single-use plastic tableware is said to be banned. In the meantime, the polymer manufacturer offers several formulations that have reached market maturity and enable a wide variety of applications. From the jury's point of view, the compound made of PLA fibers being produced from sugarcane in a PLA matrix is a genuine further development and represents a good perspective for further possible applications of the bioplastic, which is currently the most widely used material in the world. This is because the properties of the reinforcing fibers are retained during compounding as well as product manufacture. They form a good bond with the matrix without fusing with it. If they did so, the handle of the disposal fork, for example, would not bend 180 degrees, but would break as before. So, third place this year goes to Earth Renewable Technologies for the biodegradable and bio-reinforced monomaterial. Congratulations!
Congratulations to Earth Renewable Technology. Yay! Hello, the third place.
Again, it is we will send it as soon as possible, and it will be the first prize that leaves the continent and goes down to Brazil.
Yes, great, and thank you very much for sending us your idea and for participating. And now we are curious who took second place. So let's listen to the next laudation by Miss Fischer. The floor is yours.
The second prize goes to a company that has managed to produce unaffected even in times of strained or interrupted supply chains. Sourcing natural fibers and biopolymers locally processed for today's award-winning UD tapes made that possible. This does not only ensure availability, but also comes with a low footprint due to the transport routes for raw materials being quite short. From a technical point of view, the uniformity of the fibers covering the polymer really impressed the jury. The solid bond between matrix and fibers is achieved by a specially developed fiber impregnation process. Furthermore, it was impressive that a lightweight biodegradable composite material has been developed that can be produced using established manufacturing technology. This means that the material combination of polypropylene with glass fibers currently used for unidirectional tape can be replaced by PLA and biopolyamide with flax or hemp fiber reinforcement. It is also noteworthy that the development comes from a region where the transformation from lignite and conventional chemical industries to agriculture and natural materials is a major challenge. This should signal to many regions around the world that have embarked on or are planning to embark on the transformation from a fossil to a bio-based resource base. Among other things, the natural materials are used in Markkleeberg to create highly technical products that are recycled at the end of their use phase and given a second life as short fiber reinforced plastics before they can even be recycled biologically at the end of their life cycle, depending on the plastic selected. With this product, SACHSENLEINEN, which says it wants to make an active contribution to shaping a sustainable future, has succeeded in creating an award-worthy innovation that we are pleased to recognize.
Congratulations to SACHSENLEINEN GmbH. Great.
Great.
Yay. Thank you also for participating. Great. And now it's not a surprise anymore, but anyway, we are looking forward to Ms. Fischer's laudation.
The top prize goes to a product that excited all jury members equally. It is biodegradable foam developed for a broad and important field of application: sound and heat insulation. According to the material data sheet, the foam has, among other things, inherently good flame resistance, as it makes only a very limited contribution to fire and has low smoke emissions and does not drip, fall off, burning within 600 seconds. Furthermore, due to its raw materials, no toxic gases are released during combustion. The biodegradable engineered product has been developed to production readiness and has passed numerous technical tests for use in vehicles, industry, and buildings. What is further smart about the product is that it remains biodegradable when combined with any biodegradable polymer as a topcoat. With fossil-based mixed composites, the only disposal option at the end of the use phase is thermal recycling. The material formulation is in-house development and was not based in conventional bioplastics. The formulation is a combination of proteins, polyol, water, starch, and a filler, from which no polymer has been produced before, but which are used in food, cosmetic, and pharmaceutical products. The fact that the foam is completely harmless was proven by a jury's member's dog. When a sample accidentally fell off the table during the session, the dog ate it without further ado. Afterwards, he wanted another treat like that. The animal is fine. So, the insulation material also passed this unplanned test with flying colors. This was not the only reason for the winning product of the Biopolymer Innovation Award 2022. It is called Stop Sound and comes from the Belgian company Home EOS. Congratulations for this promising development.
Congratulations to Home EOS, and again congratulations to all winners. And we do hope that you are happy, and we are curious how you feel about your prizes right now. So, how do you feel about it?
Very glad to have it. It's a real pleasure for us. It's the culmination of years of effort and research, and we see now really a growing number of applications ahead of us, not only in insulation and vibration damping, but we see interest also from packaging and food industry. We see interest in unexpected fields for fire protection or from thermal insulation. So it's a great honor for us to be recognized for our contribution to sustainable development, and we have a lot of ideas to convert these products into application for various industries, but also for consumers.
Great.
Yeah, that's great. And thank you to all participants. It was, the applications were great. And next year we will hear something from Belgium, how it turned out, the prize.
We'll have a good surprise.
Yeah. Here I have a sample of the prize winner. And you have the cash prize for 2,000 euros. Will go to Belgium.
Yes.
We will make good use of it.
Congratulations to all of you. Thank you.
Thank you. And also thank you to the others. And it was great having you. And if you have another idea, please don't hesitate to send it to us.
Yes. Feel welcome. Okay, so have a great day. Most of luck to all of you, and yeah, all the best. Stay healthy, and see you soon. See you next year. Bye.
Thank you.
Thank
Bye-bye.
you.
See you soon next year.
Bye-bye. Bye-bye.
Bye bye. Ladies and gentlemen, this was this year's Biopolymer Congress. We do hope it's been informative and enjoyable, and that you'll take away many new insights and ideas. Thank you so much for your attention, your interest, and active participation. Next year we plan a hybrid event so that we can all meet again, exchange our ideas in person, and maybe even have a dance on the Biopolymer dance floor. Many, many thanks to our great sponsors GTAI, Columbia Plast, Plastico, EPMA, Exipnos, and Rubio. We would like to thank the Merseburg University of Applied Science once again for their professional and outstanding support. We are indebted to these wonderful sponsors, without whom this event would not have been possible. Many, many thanks. We look forward to seeing you again in 2023. Take care and stay healthy. See you next time. Adios and goodbye.
First of all, as president of Polycom, I want to thank you for your attention and promise you that we will also have an exciting lectures and award winners next year. There will be surely developments and applications with these fantastic biopolymers. So mark the 13th of June 2023 in your agenda. The sure fix of our community. Bye-bye and stay healthy.
Bye. Adios.
Adios.